We're going to cover simple regression in this video, and we'll break it down into the following topics. We'll do a review of correlation, and we'll also complete our review of simple regression. We did some of this last semester. For the simple regression, we'll calculate the slope and the y-intercept. In the next video, we'll cover the calculation of the source table, and we'll look also at later on at diagnostics for simple regression. So the first topic is correlation. As a descriptive statistic, we've used it to describe the relationship between two variables, two scalar variables. It tells you the direction of the relationship, a positive relationship or a negative relationship, and the strength of the relationship, which is the actual numeric value, which is between -1 and +1. There is an inferential test for the correlation coefficient. The null hypothesis is there is zero relationship between the two variables, no correlation. Alternate hypothesis, there is a correlation. So what we'll do now is I'll just walk through the calculations in the Excel spreadsheet I posted on Blackboard. So we have a simple regression class example start. Hopefully you have that downloaded. First thing we need to do is calculate our descriptive statistics. So calculate the average for variable x and the sample standard deviation. Here, decimal places, drag across. As you can see in the formula, the correlation coefficient is simply the product of the z-scores for variable x and y per subject. You multiply the two z-scores for a subject, sum them up, and divide by n-1. We divide by n-1 in this example because we're working with the sample standard deviation. If we had had a population standard deviation, we would have divided it by n, the population number. In this case, since it is a sample standard deviation, we divide by n-1. So first calculation is the z for x, and we need the z for y. As you recall, the z-score is the value minus the mean. You want that to freeze for the rows, divided by the standard deviation. I do the same with that now that I've got my formula correct. I've got my dollar signs properly located. Drag across. And now, if I've done this correctly, just as a little audit check for a z-score, the mean of a z-score is 0 and standard deviation is 1. So if I've done this correctly, I should have zeros and ones across. And I do. So my calculation is correct. Next step is to calculate the z-score, the product of the z-scores per subject. So I want ZA times by ZB. Do that for all 5 subjects. I sum that. Correlation coefficient, I need n-1, which in this case is 4. My correlation coefficient is equal to the sum divided by n-1. Correlation is 0.639. And there, 0.639. Coefficient of determination. It's a measure of the strength of association between two variables. What it tells us is, in our case, of the variance or variability in variable y, what amount of that variability is explained by its variable y's relationship to variable x. So I have the relationship, a correlation coefficient. The two variables are related. Correlation is 0.639, but what percent of that variability is explained by relationship to variable x, and that's referred to, that's r squared, referred to as the coefficient of determination. So it's equal to my correlation squared. So what that is telling me is that 40% of, or 41% of the variability in variable y can be explained by its relationship to variable x. So that's our review of the correlation coefficient. Next, we will go on to regression. So first of all, we can put our scatter plot to show the relationship. Insert. I want a scatter plot chart. Okay. Variable x will be the x-axis. And variable y is the y-axis. Now what I can see here, let's make this a bit bigger. Okay, I can see that there is a relationship between the two variables. As the values of variable x increase, the values of variable y increase. So if I take the first point, on the lowest point, sorry, variable x, which is subject 5, as a value, variable x is equal to 10, and variable y is equal to 18. So for variable x for person 5, so here, that person has a score of 10 on variable x and a score of 18 on variable y. Next is the 15, variable x at 15, and variable y at 27. So as I can see here, there is a relationship between the two variables. The greater the value of variable x, the greater the value of variable y. Now what I can do is I can insert a trend line. So I have a linear trend line, and I can see here. So the slope is positive, higher the value of x, higher the value of variable y, thus the positive correlation coefficient. My r squared is 0.41, or 41% of the variability in variable y can be explained by its relation to variable x. If that had been perfect, that would have meant that every point here on the scatter plot would have been on that line, but that's not the case. So the next thing we need to do is we need to figure out the slope of this best fitting line and where it intercepts the y-axis. And that will be the next tab in our start spreadsheet. The formulae that we're going to use are regression line fits in terms of y equals a plus bx. We'll calculate the slope, the b value, and then we'll calculate the y-intercept. So the first thing we need is we'll calculate our descriptives again, a bit redundant. Mean sample s equal to average equal to st sample and I drag those across. So my means and my standard deviations. I need the correlation coefficient, so we'll call that r. We'll calculate that very simply, and we'll do it in using Excel's functions. So Excel has a function of correlation right here. So it needs the values for variable x, and then comma, the values for variable y. And using that function in Excel, we will get the correlation coefficient, which replicates what we did on the previous slide. Okay, first thing I need is my slope function. So b, or the slope, and it is equal to the correlation times by the sample standard deviation for variable y divided by the sample standard deviation for variable x. The slope function is 0.58. Now, one feature of a regression line is, for simple regression, one point that will always be on the best fitting line is the mean of x and the mean of y. So given that one of the points on the best fitting line is x equal to mean of x, so mean of x here, and the mean of y. So I solve for that. That will allow me to calculate the y-intercept. That is equal to the mean of y minus the slope function times by the mean of x. Okay. Fix that. Now I can check that in my with my spreadsheet, or with my graph. Take this. I've just copied it over. In design, I can add chart element, trend line, go more trend options. And I want the display the equation on chart, and if I want to get the r squared too. And there we go. That replicates what we calculated by hand. So that's the calculation of the slope and the y-intercept for simple regression. And that will end this video. The next video will go on to calculate the source table for the simple regression.